Welcome to today's lesson. Today we're going to be talking about arcs and sectors. Let's now move along to arcs, sectors, and segments. The first thing we have to know is, what is a radian? One radian is defined as the size of an angle needed to cut an arc of the same length as the radius. Well, what does all that mean? Well, whatever the size of this angle is 1 radian. Because my radius is equal to my radius is equal to the arc length here is also 1 radius. That's what this says here. That is the definition of 1 radian. Radius equals radius equals radius. Whatever angle that is there is defined as 1 radian. Remember, there are 6.28 radians in one 360-degree circle. And there's pi radians, 3.14 in a semicircle or half a circle. So here are our conversions. 360 degrees is equal to 2 pi, which is about 6.28. So a full circle has about a little more than 6 radians in it. That's very helpful for me for later. And 180 degrees is equal to pi, which is a little more, 3.14, is a little more than 3 radians. So in half a circle we get about 3 radians. Well, let's do some conversions. How do I convert 90 degrees into radians? I'm given degrees, so I put degrees on the bottom. I know 180 degrees is the same as pi, so I'm going to get, when I cancel and cancel, I'm going to get pi over 4. How about if I wanted to convert radians into degrees? Say I was given 3 pi over 2, and I want to convert that into degrees. Well, times, what goes on the bottom? Radians and radians. So I know pi goes on the bottom. Pi is the same as 180 degrees. And when I cancel and multiply, I'm going to get 370 degrees. Lastly, let's say I wanted to convert 3 pi over 2 into degrees. Well, multiplication, if I have radians on the top in the numerator, I have to have radians in the denominator. Pi radians is 180 degrees. When I cancel and cancel, multiply 3 over 2 times 180, I get 270 degrees. So there's 2 quick examples of unit conversion. We just learned that this arc length L from A to B, I'm going to call that arc length L, is 2 things. We said it's proportional to the angle it subtends at the middle of the circle. Of course, if L is huge, then the angle in the center is going to be huge too. If L is small, the angle in the center is going to be small. So yes, L is proportional to theta. Also, L is a portion of the circumference of the circle. So L is a portion of the circumference of a circle. Well, you have to remember what the circumference of a circle is. It's denoted 2 pi r. So we can set up a proportion. If this L is proportional to this theta, well, this theta, we know, is a portion of 360 degrees. What's another way to write 360 degrees? 2 pi. So we're saying the angle at the center is to 360 degrees, or 2 pi, as the L is to the whole circumference. That's what this proportion means. Well, if we want to solve for L, I have to cross multiply. 2 pi L is equal to 2 pi r theta, and I can cancel my 2 pi's out, and I get L is equal to r theta. That is an important one to put away. L is equal to r times theta. Remember that, please. Here's a straightforward problem involving finding the length of an arc. It says find the length of the arc AB. Well, we know our formula, that our arc length AB, or we could call it L, is equal to r times theta. Well, L, or arc AB, is equal to, our radius is 8, and our theta is 110 degrees. Well, we can't use it in degrees. We have to convert to radians. How do you do that? Well, times degrees on top, degrees on bottom, 180 degrees. And that's the equivalent expression is pi over 180 degrees, which gives us 15.4 to 3 sig centimeters. That's our length L, or we could call it arc AB. We just talked about the length of the arc L being equal to r times theta. Well, let's talk about the area of the sector. Here's the area in red shaded. Well, what is the area of the whole circle? Of course, that's pi r squared. I don't want the area of the whole circle, I want some fraction of that. Well, what's the fraction going to be? It's going to be theta divided by 360 degrees, or in radians, that's 2 pi. Well, when you multiply the whole area, pi r squared, by this fraction, theta over 2 pi, our pi's cancel, and we're left with r squared theta over 2 is the area of any sector. Please remember that as well. Here is a straightforward example of finding the area of a sector. If I'm given this diagram here with a radius of 7 and a theta of 3 pi over 4, that's in radians already. I don't need to convert that. I want to know the area of this sector in blue. Well, I know the area formula is theta r squared divided by 2. It's a matter of just plugging and chugging. Theta is 3 pi over 4, r is 7, I'll square that and divide the whole thing by 2. And when I do the 3 sig figs, I get 57.7 centimeters squared. That's the unit of the area. Now, if they ask me to find the perimeter, that would be 7 plus 7 is 14, plus if this is A and this is B, we call this arc length L, we could easily find L by saying L is equal to r theta and adding that to 7 plus 7. The units of this, of course, would just be centimeters.